Okay, so prove by induction that for n is a number of integers, positive integers in this case, that this matrix is equal to what we have here. So to start with, let us just make an assumption that A is equal to this matrix here, like this. So matrix A is this one that we have here. This means that A to the power n is equal to this. So we can say, so A to the power n is equals to 3 power n, 3 power n minus 1. Here we have a 0, here we have a 1. Okay. So now that we have this, let's go ahead and prove this by induction. So proving this by induction, we're going to start with step 1, of course. Step 1, we're going to prove that it is true for n is equals to 1, the simplest positive integer we can get. So step 1 is also known as the base case. So for the base case, we prove for n is equals to 1. So in doing so, we simply say we get what we have here and say where there's n, replace it with 1. So that we get a to the power 1 is equals to 3 to the power 1. Here we have 3, bracket 3, power 1 minus 1, 0, 1 there like that. So this will give us a is equals to, or a power 1 is equals to 3. So 3 minus 1 is 2, 2 times 3 is 6. We have a 0 there, we have a 1 there like that. Okay, so we can see that this is just the same as matrix A. So this is true for n is equals to 1. So we can conclude by saying true for n is equals to 1. In short, we're saying this statement is true for n is equals to 1. Then from there now, let's go to step 2. So this is our step 1. Let's go to step 2. Step 2 is what is known as the inductive assumption. Inductive assumption. So for this one, we just assume that it's true. So we assume that it is true. It is true for n is equals to k. So since it's just an assumption, what we can do here is we can just say where there's n, just replace it with k. We're assuming that it's true. So we'll have a to the power k is equals to 3 power k, 3 open bracket, 3 power k minus 1. Here we have a 0, here we have a 1. Okay, so it's just an assumption, so it ends there. Let's move on to step 3. Now, step 3, just mark it here. Step 3, we have to prove that it is true for n is equals to k plus 1. Now, for this step, it is critical that you do something that is going to help us. And here's the something I'm talking about. So away from what we're doing in step 3, you can just do this separately, somewhere separately, where you say this statement that you have, replace n with k plus 1. So what we get? We'll have a to the power k plus 1 is equals to 3 to the power k plus 1. Here we have a 0. Here what do we have? We'll have 3, open bracket, 3, k plus 1, minus 1. Here we have a 1, like that. Now, you don't have to show this. You have to prove it. Now, like I said, just write this down somewhere because this is going to help us at some point. So we'll come back to this and I'll show you how it will be helpful. Now, let's go back to what we're looking for. We're looking for, we're trying to prove that it is true for n is equal to k plus 1. So what does that mean? We're saying that a to the power k plus 1, which is this part here. Now we know that k plus 1 is just the same as a to the power k times a to the power 1. Because if the bases are the same, we can simply add the powers if the bases are multiplying, of course. Now, a to the power k we have. This is a to the power k from step 2. A to the power 1 we have. This is from step 1, this one here. So now that we know that we have a power k and a power 1, we can just do the substitution. So we can say this is equals to, what is a power k? A power k is 3 to the k. We have 3 to the k minus 1. Here we have a 0, here we have a 1. So this is 3 to the k. Now, this is of course multiplying with 3 to the power 1, or rather, sorry, 8 to the power 1, which is this matrix that we have here. 3, 6, 0, 1. So, multiplied by 3, 6, 0, 1. So, like I said, this is matrix A to the k, this is matrix A to the 1. So the two matrices are multiplying, meaning that we're going to need to apply matrix multiplication, row by column, of course. So A to the power k plus 1, what do we get? Row by column. So this row times this column. So 3 to the k times 3, we'll have 3 to the k times 3. 0 times 6, we just have a 0. 3 to the k times 0, we'll have a 0. 0 times 1, we'll have 0. This whole thing that we have here, so this row times this column, so this times that 3, we'll have 3 times 3. So this 3 times that 3, then open bracket, 3 to the k minus 1. Then 1 times 6 is simply 6. 1 times 1 is 1. Is that okay? Or let's say 1 times 0 is 0 first. Then 1 times 1 is 1. That makes sense. Okay. So a to the power k plus 1, this will be equals to. So what we're going to get now is, for this part, we can clearly see that 3 and 3 are multiplying. So this will just give us 3, k plus 1. The powers will just add. Here, what is going to happen? Let's factor out what is common. What is common here and here is 3. So factor out 3. What remains? What will remain here will be 3k minus 1. What remains here will be a 2. Because remember, we factored out a 3. There we have a 0, there we have a 1. So a to the power k plus 1, this will give us 3 to the power k plus 1. Here we have a 0. So we factored out a 3, that's fine. So what will happen inside? So 3 times 3 to the k will be 3 to the k plus 1. Remember, the bases are the same, the powers will add. 3 times 1 will simply be 3. Then there's a plus 2 that we haven't used yet. There's this one that we have here. Okay. So a to the power k plus 1 is equals to 3 to the power k plus 1. Here what we have, we'll have 3 outside the bracket. Inside the bracket, we'll have 3k plus 1. Negative 3 plus 2 is simply minus 1, like that. Here we have a 0, here we have a 1. Now, we're done. You can see that this result is the same as this. Now, how did we find this? We just replaced in our statement to say, just replace n with k plus 1, we had this. But if you solve it, this is what you get. So since this statement is true, it's the same as this one, then we can say, since it is true for n is equal to k plus 1, then the statement, what's the statement? The original question. The statement is true by mathematical induction. Simple as that. So there we have it. State the period, amplitude, and phase shift of the function y is equal to negative 1 over 2 tan, open bracket, x minus pi over 2. Okay, so to start with, there are some basic things that you need to know. So here are the basic things. A function which is supposed to be sketched or graphed, what you need to know is this. It will be written in the form y is equals to a certain, or rather before that, a, then a certain trig function. So a trig function, b, open bracket, x minus c plus d. When we say a certain trig function, it can be a cos, it can be a sine, it can be tan, it can be cosec, anything. So here where there's trig, you can just use any trig function. In this case, the trig function that we have is what? Is tan. So we can clearly see that the coefficient of the trig function is a, will be half in this case. Now, what do these letters represent? So a represents the amplitude. A represents the amplitude. The amplitude is also known as the vertical dilation. This is the vertical dilation. Vertical dilation. It's being dilated vertically. The next thing is, let's talk about B. So what is B? B is what will help us to get the period. So if you have B, then B will help us get the new period. We'll just say the new period. I'm saying the new period because in this case, the period will be equals to 2 pi over B. So whatever value of B you have here, you just replace with this B here, then you have your period. So 2 pi over that value, then you have the period. Okay. Period is also known as the horizontal dilation, more like the opposite of this one. So it's the horizontal dilation. So C, now let's go to C. C is known as the phase shift. So C is the phase shift. Phase shift, in this case, our phase shift, we just pick it what we have there. So this is our C. Our C is just, this is supposed to be D, sorry. So our C is just that what we have there. Okay, we'll talk about it in a bit. So D, lastly, is the vertical shift. D is the vertical shift. So it's important to note that the phase shift is also known as the horizontal translation. So now, if you have been given an expression, then they ask for amplitude, period, phase shift, or vertical shift, you just pick up the letters that you have there. Now, for this one, we don't have the vertical shift, unless if they had said plus maybe 2, then that 2 is our vertical shift, which is D. So let's answer the question at hand now. We can clearly see that whatever is before the trig function is the amplitude. So would be tempted to say for our question that the amplitude is negative half. But in actual sense, the tan function does not have an amplitude because it has no maximum or minimum value. If this was maybe a sine or a cos, we would have said the amplitude is whatever is before the sine or the cos. So for the amplitude, we can say tan has no amplitude. So amplitude, remember that's what it says, amplitude, period, phase shift. So amplitude for this question now. Amplitude, what do we have? Doesn't exist. So does not exist for a tangent or a tan function. Why? Because it has no maximum or minimum. So we're done. Remember, amplitude is the displacement which a wave is being displaced at, either going up or going down. But since this one has no maximum or minimum, so it will just go on and on and on. That's the reason why we're saying that it has no amplitude. The next thing we can talk about is the period. What is the period of our given question? So remember, the period is B. So what we have outside this bracket here, if you have a number here like 2x, factor out the 2 so that the 2 comes here. But in this case, B, there's nothing there. So that is where our B is. So our period, which is our new period, will be 2 pi over B. What is B there? 1. So our period is simply 2 pi. Next, phase shift. Now, phase shift, this one is just straightforward because for our phase shift, we just get what we see inside the bracket there. Phase shift is C, meaning that our phase shift here is what? Pi over 2. So the phase shift is simply pi over 2. As simple as that. We don't have the vertical shift because we have nothing there. So the vertical shift in such a case is 0. Okay, that's it. Hi guys. So we have this question in the vectors, which reads, show that the line, this line that we have here, which is in vector form, is parallel to this plane. Okay. So the first thing we have to do is we have to find two vectors, which is the direction vector and the normal vector. So the direction vector of the line is found by this column vector here, which is 4, 3, and 1. So the direction of the line is given by, let's just use m. So m, what we have is 4, 3, and 1. This is the direction. Then from the plane, we can obtain the normal vector. So the normal vector from the plane are just the coefficients of x, y, and z. So the normal vector, the coefficient of x is 1 here. The coefficient of y is -2. The coefficient of z is a +2. Okay. So for the plane and the line to be parallel, it means that the normal and the line should be perpendicular to each other. Or rather, the normal and the direction of the line must be perpendicular to each other. So to show that the line and the normal are perpendicular to each other, the dot product must be equal to 0. So m dot n should be equal to 0. So vector m is 4. Let's use component vectors. So vector m is 4i plus 3j minus k. And vector n, which is the normal, we have I minus 2j plus 2k. So let's show that this is equal to 0. So 4i times I, we get 4. 3j times 2j, we get -6. K times 2k, we get a +2. So this gives us -2 plus 2. And what we get is a 0. So this shows that the normal and the direction of the line are perpendicular. And once you show that the two are perpendicular, it means that the original vector and the plane are actually parallel to each other. So just like that, we have shown. Thank you very much. Hello, everyone. So we have this question under vectors. Let's see how we can break it down. The question reads, show that the line, this line which is in vector form, lies in the plane, this one that we have here. So what we're going to need to do here is, we're first going to need to convert the line, which is in vector form. Let's convert it to parametric form. So it's important to note that this vector that we have here can be represented as xyz, which is equals to 2, 1, 0, plus s, 5, 1, -1. So this vector can be represented like this. Then to convert it into parametric form, what we're going to do is we're going to get everything in the first column, which is x, 2, and 5. So that we get x is equals to 2 plus 5s. In the second column, we have y is equals to 1 plus s. In the third column, we have z is equals to 0 minus s. Okay. So now that we have these three, these that we have here, these are in parametric form. So what we're going to do is we are going to substitute in the plane. So the plane, the equation of the plane is x minus 3y plus 2z. So this one can cross the cosine, so that we can have +1 and everything is equal to 0. So we have to show that whatever we have here is equal to 0. Then that shows that this line is found in this particular plane. So here where there's x, we're going to replace it with 2 plus 5s. minus 3. Here where there's y, we're going to replace it with 1 plus s. Then lastly, here where there's z, same thing. We're going to replace z with negative s. Then we're adding this 1 that we have here, and we have to show that this is equals to 0. So let's prove this. So we're going to have 2 plus 5s minus 3 times 1, that is 3. 3 times s, that is negative 3s. 2 times negative s is negative 2s plus 1. So we have to show that this is equals to 0. From there, we're going to say, let's group like terms. We have 5s and 3s. So that will give us 2s. We have 2 and negative 3, so we'll get negative 1. Remember, we still have 2s, and we still have that 1 there. So 2s and negative 2s will just give us a 0, plus negative 1, positive 1 will just give us a 0. So 0 is equal to 0. So this shows that the line lies in the plane. Since after substituting, what we got is a 0, then this shows that this particular line, which is in vector form, lies in this plane. So that's how it's done. Thank you very much. Find the point of intersection of the plane, or I should say of the planes. So these are the 3 planes that we have. Okay. So the first thing we're going to do is we're going to put them in Cartesian form of an equation of these particular planes. So this is what we're going to do. For this one, these they are first of all in vector form, so we're going to change them to Cartesian form. So this represents x, y, z, x, y, z, x, y, z coefficients. So the one that we're calling R1 in this case can be written as x plus y minus z is equals to 9. So we're just obtaining the coefficients in that order. So the next one will be R2, which is 3x plus 4y plus 3z is equals to 2. Then the last one is R3. We're using 4x plus 5y plus 3z. This is equals to 3. Okay, so now let's put them together in this way. All 3 equations together, we have x plus y minus z is equals to 9. Second one is 3x plus 4y plus 3z is equals to 2. Then we have 4x plus 5y plus 3z is equals to 3. So let's find the point of intersection. So to find the point of intersection, let's give them, let's label them. Let's call this 1. Let's call this 2. Let's call this 3. Okay. So from equation 1, let's make, which one? Let's make x the subject of the formula. This is what will happen. We'll have x is equals to 9 minus, so the y crosses the equal sign, becomes a negative. The z crosses the equal sign, becomes a positive. So this is just the subject of the formula coming from equation 1. Let me even do this. Now we should substitute this into equation 2 and also into equation 3. So this is what will happen. If we substitute it into equation 2, we're going to get 3x, or rather, where there's x, we're supposed to substitute with this. So 3, open bracket, 9 minus y plus z. We've substituted x, so plus 4y plus 3z is equals to 2, like that. So if we expand, we'll have 27 minus 3y plus 3z plus 4y plus 3z is equals to 2. Let's group like terms. So the y and the y, if we put them together, we just get y. The z and the z, if we put them together, we get, sorry, why am I writing equals? So the y and the y, we get y. The z and the z, we get 6z. Then the 27 will cross the equal sign, so this will be negative 27 plus the 2 that we have there already. So y is equals to, if we make y the subject of the formula in this case, we can say this will give us negative 25. The 6z will cross the equal sign to give us minus 6z. So we'll come back to this. Now, let's go back to the subject of the formula, which came from equation 1. So from this equation, by the way, let's call this equation 4. The subject of the formula, let's substitute it into equation 3. So what we get? We'll get 4. Where there's x, we replace with 9 minus y plus z. Like that. Plus 5y plus 3z. All this is equals to 3. Like that. Okay, let me just do this. Then we can say, let's expand. If we expand, we'll have 36 minus 4y plus 4z plus 5y plus 3z is equals to 3. So let's group like terms. Y and y will have y. Then we have z and z, so that will be 7. 7z. This is equals to 3. This 3 here minus 36. Again, let's make y the subject of the formula. So y is equals to negative 33 minus 7z. Let's call this equation number 5. Now, if you look at what we have equation 5 and equation 4. So what we need to do is, since y is equal to this, y is equal to this, let's just compare these two equations. So what do we obtain? What we're going to obtain here will simply be negative 25 minus 6z is equal to this one as well. Negative 33 minus 7z. Let's group like terms. So left hand side, negative 6z plus 7z is equals to negative 33. This goes to the other side and becomes a positive 25. We add these two, what do we get? We get positive z. We add these two, what we get? Negative 8. So we have the value of z, negative 8. So since we have the value of z, how can we find the value of y? To find the value of y, just choose one of these two equations. Any of the two will give you the answer. So I'll opt to go with this equation here. So I'll say y is equals to negative 33 minus 7. Now remember, z is negative 8. Like that. So y will be equals to negative 33 plus 56. Like that. So if I add these two values, the value of y will simply be equals to a positive 23. So we have y. Now we have y, we need x. How do we find x? We go back here. So to find x, we can say x is equals to 9 minus, what is y? 23. What is z? Negative 8. Like that. So if we add everything that we have here, the value of x will simply be equals to negative 22. So we have x, we have y, and we have z. Now remember, the question says find the point of intersection. So the point of intersection is x, negative 22, comma y, 23, comma z, negative 8. So this is your point of intersection. Very straightforward.